in public meetings or public sectors, uh, you have been observing that the case is the so you have been observing that the case that in so many public meetings we are using the sound systems. There only we are using the amplifier. So why do we use amplifier? Means it is going to be strengthen the signal here. That means whenever a person is going to be giving a speech, or other person which is going to be playing a song here, there only, if it is a less volume is there, the amplifier, in that amplifier, you can have a volume base triple is there. So by using these here terminals, you can easily enhance the signal here. That means you can easily enhance the volume, bass, triple, mic, everything. So that means here, what is the main role of the amplifier? Amplifier is going to be strengthen the signal. Which signal? A weak signal is going to be strengthened by the amplifier. So what is an amplifier? Transistor is an amplifier. I think so. I have been already studied in your fifth semester. Okay, but so here the transistor which is going to be act as an amplifier here. Most important short question is there. Okay. So here, so the thing is that the function of differential amplifier, which is to be amplify the difference of the two signals. Okay. So the need for the differential amplifier in many physical measurements arises where response from the DC direct current to many megahertz 10 power 6, which is required, uh, which is uh, which is the basic input stage of an integrated amplifier. So the thing is that uh, the block diagram for the differential amplifier, which is indicating this here, you can see this. This is the differential amplifier, and which is a signal here V1, which is having the voltage is V1. Another one is having the voltage is V2 here, and the terminals are positive and negative terminals are there. The difference which may gives you here VD, difference voltage VD, and if it is fed back through this differential amplifier, you may get the here output voltage V0 here. The symbol indicating this is grounded here, this is also grounded, this is also grounded here. But the thing is here V0, which is always proportional to the V1 minus V2. What is V1 minus V2? Which is nothing but a VD, differential voltage. So you can observe the diagram for the basic configuration of a differential amplifier. So here uh, you may have, you can see this is a one transistor. This is the another transistor. Okay. So this is the Q1 and this is the Q2. And here, what type of, which transistor it is? NPN transistor. Okay, this is also NPN transistor. Okay, now? So why it is NPN? The current which is flowing toward the emitter. Bottom is emitter. RE means emitter is there, bottom. RC means capacitor is there. So center one is a base. So the current which is flowing from the base to the emitter, which is occurred in the case of NPN transistor. Okay. So this is the emitter resistance RE, and this is the minus VE, and this is the plus VCC. and this is the RC. Okay, RC1 or RC2, whatever it may be here. Capacitor resistance above and bottom is the emitter resistance, and the center one, which is a base here. This is the signal we are sending. This is what type of signal it is? Indicating the AC signal, positive half cycle, negative half cycle. What type of wave it is? Sinusoidal wave. Sinusoidal wave. Okay. So this is the signal resistor. The same which you may be applied, you can see in LHS also, left hand sides. Okay. What is this? The difference between these two transistor V naught. Okay, now. So the output signal in a differential amplifier, which is always sorry, which is always proportional to the difference between the two inputs. So V naught is there, V naught which is proportional to the V1 minus V2. What is V1 and V2? Two input signals. Okay. And what is V naught? Single ended output. Okay, now. So how to calculate the differential gain? Differential gain. So let you know about the equation for the gain. Gain is nothing but the ratio of the output voltage to the input voltage. Okay. V naught by Vi is nothing but AV, gain of the amplifier. V naught by Vi. Output voltage to the input voltage, which may gives you here gain of the amplifier. So here differential gain, which is indicating differential in place of AV, AD. V naught by Vi. What is Vi? V1 minus V. So what is V naught? AD into V1 minus V. Is it clear? So the same equation you have been written this equation. So this may gives you here a differential gain of an amplifier, where AD is the constant proportionality, and which differential amplifier amplifies the difference of the two input signals. And also it is known as a differential gain of the differential amplifier. AD equals to V naught by VD. VD is nothing but a V1 minus V2. So this may be written as the fraction which is minus GM into R's. Next, common mode gain. So this is indicated here. Common mode gain is AC. So an average of the two input signals. Difference is here differential mode amplifier is gain, and here common mode gain is average V1 plus V2 by 2. So the differential amplifier also produce the output voltage which is proportional to the common mode signals. So V naught equals to AC into VC. What is AC? The ratio of the negative sign ratio of the RC, collector resistance to the emitter resistance, is nothing but AC. So which is going to be exhibiting some finite output for V1 equals to V2 due to the common mode gain. So what is the total output of any differential amplifier, which may gives you here V naught equals to AD into VD. VD is nothing but a V1 minus V2, and AC into VC. What is VC? V1 plus V2 by 2. Okay. Next, another important is the common mode rejection ratio, CMRR. So the ability of differential amplifier uh, to reject a common mode signal. The ability of a differential amplifier to reject uh, a common mode signal, which is defined by the ratio, which is called a common mode rejection ratio. So CMRR is defined as the ratio of the differential voltage gain AD to common mode gain AC. AD by AC is nothing but a CMRR, which may gives you here GMR. So what is CMRR value? 20 log AD by AC into AC decibel. Okay. See the sound. So what is input and output resistances? Difference mode input resistance is 2RE. Output resistance is RC by R. So this differential amplifier which may be used in FETs also, field effective transistors. Okay. How to calculate the gain? So in depth we are not discussing, but you don't have these many according to in our syllabus. Around steel. ఆడుకున్నాక దుక్కుదాకా అది దాన్ని అంటున్నా ఏది ఎక్కడ So let us discuss about the basic differential amp. Okay. So this is on in our syllabus. And also from the textbook we are discussing. So we can go for that. The differential amplifier, which consists of the two identical transistors T1 and T2. In previously in my PPT, have been indicated the in place of Q1 and T1, T2 is a Q1, Q2, which is having identical resistors in their collector circuit. The two halves of the circuits are perfectly matched. So, and the emitter which are connected to the minus VE via emitter resistance RE properly bias the two transistors, and which may have the power supply plus 15 volts to minus 15 volts. The emitter resistor, that is RE, which is the heart of the differential amp. So which is going to be limiting the current available for two transistors to constant current I naught. Okay. That means here in emitter section, which is having a emitter resistor for first transistor, and second transistor is also having another emitter resistor. So that which is going to be constituting the first transistor, which may constitute the emitter current is IE1, and other transistor which may constitute the IE2 current. So that these are to be stabilized. These are to be here gives a constant current which is only by the emitter resistor RE. So whenever these currents which are fed through the RE, so this is going to be here limiting the current. That may be IE1 plus IE2, which may gives you I naught. So that is a constant current. So that's why this RE is the heart of the differential amplifier. Okay. So I think so you got it. And this RE minus VE combination act as a constant current source. So which may gives you a constant current source. So this differential amplifier which has a two input terminals, the output voltage which is measured across the two collectors. So let the voltage of equal magnitude and same polarities to be applied between the one between terminal 1 and the ground. Here a ground is there. Where the ground? Here is the ground. Here is the ground. This is V1. And here this is the V2. Here the ground is V, another ground. This is the first one. This is the second one. And transistor T1. This is the transistor T2. So this is the RC value. This is also RC. But the thing is that here in collector region, you may have the resistor is RC. So that if the voltage is V1 and RC is there, IC1 current. Here V2 is there, RC is there, IC2 current. Okay. The difference between the IC1 and IC2 or else V1 and V2 is V0 output voltage. Getting my point? And whereas here you assume two other resistors, the current which is fed through this emitter region is IE1 and IE2. The difference which may gives you here the average, the sum of these IE1 and IE2 which is going to be stabilizing here when it is fed and passing across the emitter resistance RE is I0. This is I0. Okay. So this is minus VE and this is the plus VCC. Okay. So here the causes equal changes in the collector current and potential difference between two collectors will be zero. This means that the voltage is common to both the terminal, do not affect the output voltage. Let you try to understand the concept. It has a two input terminals, 1 and 2. Output voltage measured across the two collectors. Let the two voltages of equal magnitude and the same polarities, which may be applied one between the terminal 1 and ground and other between the terminal 2 and ground. Okay. I already shown you in the diagram itself. So this causes equal changes in the collector currents and the potential difference between two collectors, which will be zero. So this means that voltage is common to both the terminals and which do not affect the output voltage. If the base of the transistor T1 is driven positive with respect to the base of the transistor T2, and the current through the T1 which increases the current through T2 decrease by an equal amount so that I0 remains constant. If one is increasing, other should be decreases and the output current I0 remains constant. So that here IC1 which is greater than the IC, which is a potential difference which develops between the two collectors. And that is a differential input voltage which may causes the differential output voltage. So the mode of operation is a differential input and differential output. And other words, the difference amplifier which may be used in the single-ended output. Let you know about the one of the input which may says the base of the T2 via small resistor, a positive input of at the base of T1, which may results in a negative output of its collector. That it is going to be acting as an inverting amp. What it is? An inverting amp. And this is referred to as a single-ended input. and single-ended out in inverting mode. So in this mode of operation, the current in transistor T1 increases when its base is given a positive potential. In order to maintain the output current I0 is a constant, the current in D2 is also going to be decreases by a single magnitude. As a consequence, the output voltage at the collector of the T2, which will be positive. So if we give the input to the base of the transistor T1, and if it is going to be take the output at the collector T2, and which maybe works as a non-inverting amplifier. What are the characteristics of the differential amp? Uh, what are the characteristics means here? Here, this is the figure. These are the two input signals V1 and V2. Only one single output is there. Okay, note is no two, only single output is there. AD is the gain of the differential amplifier, AD. Okay, here it is grounded. So V0 equals to AD into V1 minus V2. That is called VD. What do you say? V1 minus V2 is VD. Okay. And also another common mode rejection ratio. VC equals to here average of the input signals here. V1 plus V2 by 2. And the VD value is V1 minus V2. Okay. So the output and input voltage relation. V0 equals to AD into V1 minus V2 plus VAC into VC. So simply you can remember this. The thing is that the ratio of the differential and the common mode gains AD by AC, which is indicating the effectiveness with which the amplifier rejects the voltage common to both the input signals. And this is termed as a CMRR for rho. So CMRR is nothing but a AD by AC into rho. And for a good amplifier, differential amplifier, the CMRR value in decibels is 80 to 120 decibel. Okay. For in practical difference, the amplifier V0 equals to AD into VD of 1 plus 1 by CMRR into VC by VD. Problematic question. Here the summary which may gives you here the difference amplifier or the differential amplifier has a two inputs, only one out. Okay. So the most important characteristics of the differential amplifier is that differential gain and differential gain AD equals to here V0 by VD, V0 by VD and CMRR. Okay. So amplifier has a two input terminals and the output which is measured across the two collectors. Two collectors, not by the two emitters. Okay. Plus VCC is there. So the difference amplifier is also be used in a single-ended output mode. In examination point of view, in detail, draw the circuit diagram of differential amplifier and explain its action. Give an expression for the gain of the differential amplifier. Is it clear? CMR also. Common mode rejection ratio. So many times this question is asked as a short question. The ratio, what do you mean by CMRR? The ratio of the differential and common mode gain, indicating the effectiveness with which the amplifier rejects the voltage common to both the inputs. Subjective. Next is the operational amplifier and its characteristic parameters. First, let me give you an introduction about this operational amplifiers. So DC amplifiers with the high gain in high input impedance, ZI, okay, which has a large bandwidth and a low output impedance, which was originally designed to perform mathematical operations. What are the mathematical operations? Addition, subtraction, multiplication, integration, differentiation, etc. So many are there. So hence the name is operational amplifier. Okay. They were widely used in analog computers and other equipment. It has acquired the name versatile operational amplifier. Simply op-amp, operational amp. So what is the output voltage? V naught equals to A naught into V plus minus of V minus. So V naught equals to A naught into V plus minus V minus. What is A naught? A naught is the open loop gain. Open loop without feedback. What do you mean by feedback? Means the fraction of an output which is connected to the input. Then that is nothing but the circuit which is under in feedback. So here without using the feedback, there only if you want to calculate the ratio of the output voltage to the input voltage, then that is called gain. Okay. So here the V naught is the output voltage and V plus and V minus are the input voltage. So gain of the gain value, which is in the order of 10 power 5 to approximately 10 power 8 for purpose of the op amps. What are the characteristics of an ideal operational amp? So what are the characteristics of an ideal amplifier? Open loop gain, A naught is infinity. Input impedance, Zi is infinity. Output impedance, Z naught 0. Bandwidth, infinity. CMRR, common mode rejection ratio, infinity. Okay. And the slew rate is infinity, stability S is infinity. So the slew rate which is defined as the maximum time rate of change. So it is defined as the maximum time rate change in the output voltage without a distortion. What is the mathematical expression? S is dV naught by dt. S will be performing of the operational amp, high frequencies. So if no current which flows into the op amp, so the thing is that the equivalent circuit of an ideal amp, which is showing in this below diagram, uh, the above characteristics which are very useful to the op amp. If no current flows to the operational amplifier, is the input impedance is infinite. Okay, V plus minus. Uh, so the thing is that here the difference V plus to V minus is Vi, and this is the output voltage V naught equals to A naught into V plus minus V minus. Input impedance Zi is 0, which is infinity. And here Z naught is 0, A naught is also. So the ideal amplifier, its infinity bandwidth, which makes the phase difference between input and output voltages, which is independent of the frequency, and the performance of the amplifier, which may depends only on the external feedback network, as its uh, gain is infinite. The characteristics which are cited above only for ideal, and it is not possible to achieve them in practice. So the operational amplifier presently being fabricated using an integrated circuits ICs. The whole circuit is engraved on a silicon chip. So what are the characteristics of a real op amp? Op amp gain is 10 power 5 to 10 power 8. The bandwidth product gain bandwidth 100 megahertz. Input impedance Zi is 10 power 5 to 10 power 12. 10 power 16 ohms for special purpose. MOSFET input op amp. Metal oxide semiconductor field effective transistor. MOSFET. So output impedance is Z0, 1 to 10 ohms. And the CMRR, common mode rejection ratio, is 80 to 140 decibel. Actually, CMRR in differential amplifier, there only we have been discussed that 80 to 120 decibel. Here we are getting in op amp 80 to 140 decibel. Okay. So here offset voltage as well as offset current and slew rate is also given. So what is the here operational amplifier block diagram? You can go for the block diagram here, which is essential, which is not essential to know about the what is inside the IC integrated circuit op amp in order to use the profitably. User feel comfortable when it is has some idea about its design, and the block diagram, which may consist of a general purpose IC integrated circuit op amp. Here the first stage uh, in all types of op amps as the differential amplifier. It has a two input terminals. See here, V plus and V minus. The amplifier amplifies the difference in the voltages here in between, which is applied between the two input terminals. DA means differential amplifier. And again, which may convert into the input voltage into output currents or output voltages. Okay. The second amplifier, SEM means second amplifier, which convert these currents or voltage into single-ended current or voltage, single line. Is it clear? Okay. Single-ended. Hence, it is called differential to single-ended convert. Differential to single-ended convert. This single-ended output current is converted into voltage by the third amplifier, this one. Okay, so the final output stage of an output driver is as a low power amplifier, and which is used to boost the power and to provide a low output impedance. Okay. These are the feedback arrangements. So it has a two input terminals. So INV means inverting, NA means non-inverting. If positive terminal is a non-inverting, minus is inverting. Plus VCT to minus VCC. The terminal marked negative is called the inverting input terminal. And plus terminal, plus is marked, that is a non-inverting terminal. And whereas the plus and minus signs indicate the phase relation between input and output voltage. Whenever a positive voltage is applied to inverting terminals, results in a negative output. There is a phase inversion between input and output signals. The same voltage applied to non-inverting terminals results in positive output. So the output voltage is defined as the input signal. So here the batteries are power supply we are using to energize the op amp, and ground terminals are not usually shown in this schematic. So you can see here. So this is a inverting configuration. Okay. VI input voltage, this is the output voltage. Grounded, positive terminal which is grounded. Only negative terminal are there. Here the resistance is ZI at input, RI, whatever. In a RF transfer, uh, this is ZF. So the closed loop gain of op amp. V naught by Vi is AV, ZF by J. So for non-inverting configuration, AV plus equals to 1 plus ZF by ZI. I will share you one PPT so you can have an idea. Okay. So characteristics. What is an operational amplifier? Op amp is a direct coupled high gain amplifier which is consisting of one or more differential amplifiers. followed by level transistor and output stage, and it is a versatile device that can be used to amplify AC as well as the DC input signals, and which is designed for computing mathematical functions such as addition, subtraction, multiplication, division, like that. You can see the op amp symbol. Plus is here non-inverting, minus is inverting. What are the ideal characteristics of an op amp? Well, so open loop gain is infinity. Okay. And input impedance Zi is infinity. Output impedance Z0 is 0. Bandwidth P is infinity, and which is a 0 offset when output voltage 0. When it is output voltage 0, if V1 equals to V2 equals to 0, V1 minus V2 is also 0, then that is called 0 offset. Okay. So inverting of operational amplifier. In our textbook, we had a in place of RF is a ZF, RI is a ZI. No need to worry, whatever it may be here. Okay. So this is inverting operational amplifier. If a negative terminal, here is a negative terminal, put negative terminal, which is an inverting amplifier. You can see here we input, there is a resistor, R input is there. If V and R is there, according to Ohm's law, V equals to IR, there is a I. And here VB is 0, and VA is also 0, and it is grounded here, positive terminal, which is grounded. So that here RF input to the output, which is connected here, there only IF of current is there. So what is the output voltage? Minus of, this is the minus of V in RF by RI, which is nothing but a output voltage for the inverting operational amp. What is non-inverting amplifier? Non-inverting means VA is plus, only VB is minus. Output of the voltage which is connected to the input. So that this is the feedback resistance RF, this is the input resistance RI. Okay, na? So what is the output voltage in this case? V input into 1 plus RI by R. Next is the voltage follower. Plus is there and minus directly, no resistance. So V out equals to V in, that is voltage follower. What type of inverting amplifier it is? Which is a non-inverting amplifier. Okay. So what are the DC characteristics? Offset current, offset voltage, like that. So what are the parameters for the operational amplifier? So here, first of all, open loop gain A naught. The op amp, the gain of an op amp without any feedback. It is defined as the ratio of the change in the output voltage to the change in the differential input voltage. Okay. So the ratio of the change in the output voltage, delta V naught by delta Vi. For normally specified at the DC, the operational amplifier, which is used under the open loop condition, and the gain is sufficient as the determined accuracy of the transfer. So A naught is the output loop gain, common mode voltage gain AC. So the ratio of the change in the output voltage to the change in the input voltage when the both the input terminals are tied together. Okay. Next, CMRR, common mode rejection ratio. When two signals are applied to both input simultaneously, or a single common voltage is applied to two inputs tied together, called CM common mode signals. For an ideal op amp, it should be 0 if there is no difference in the amplifier phase of the two signals, which is applied to its input. In a practical op amp, because of the slight difference for the inverting and non-inverting inputs, there will be some finite but some so this is the CMRR. So this CMRR, it is desirable to keep AC, common mode rejection ratio gain here, common mode gain, to be very low value. It is only then that the amplifier will be able to reject noise common to both sides. The ability of an op amp to reject the common mode signals is indicated by the CMRR, and it is defined as the ratio of the differential and common mode gains. కొట్టేసుకున్నావా ఎవరిస్తున్నాను So the thing is that here it is defined as the ratio of the differential and common mode gains. So you can go for the examples here, CMRR, AD by AC, the ratio of these two. In decibel is also 100 decibels. What is the bandwidth? The open loop bandwidth, which is defined the frequency at which A naught, which falls 3 decibel from the maximum value. You can see here the gain of an amplifier, which is reasonably constant, and up to this. This is the bandwidth. A naught is the gain. Okay, 100 decibel. There only. After this, 10 hertz frequency, which is falling down. Okay. Next is slew rate, which is indicated by the S here. The capacitors in the op amp limit rate at which the output voltage can change. So, which is depend at the maximum time rate of change of output voltage without distortion. Without distortion. That is called here slew rate, which is specified by the slew rate is 1 volt per microsecond. The lower values of slew rate results in the distortion of large amplitude signals, even though they are with pass band of the amplifiers. So V naught equals to Vp sine 2 pi ft. So the rate with respect to time, which may give a peak value of the output voltage, and there is a maximum frequency f for the signal to appear the voltage without energy. Next, offset voltage is V naught, that is VOS naught. The op amp in general gives an output voltage is called the offset voltage, even if the input terminals are earthed or grounded. Okay, this is due to the lack of the symmetry mismatch in the input differential stage of the op amp during fabrication process. Next is the bias current. Bias current means here two bias currents, IB plus and IB minus, flow into, I means current here, which flow into two input terminals. Here you can see here. Okay. When the input voltages are 0, these are the currents used to bias the input resistors with the balanced amplifiers with equal input impedances. Here, the currents largely cancel. Hence, the difference between bias current, which is called offset current of an interest. The range is 100 nanometers. Nano amperes, not meters. Current is which is measured in amperes. Okay, this is the case. So this here the block diagram of op amp explanation function, and what about the parameters of op amp? Sometimes these three may be asked as an essay question. Offset voltage, offset current, and CMRR of an op amp. So this ends our this unit. Okay. Naki. So by tomorrow we will discuss operational amplifier configurations and analysis. Okay. So this we will discuss in tomorrow's class. So thank you, one and all. I'm signing off.